Today's session is about Vogel's approximation method. It is one of the methods to solve transportation problems, which is seen in operation research. Vogel's approximation method, VAM, is one of the methods used to calculate the initial basic feasible solution to a transportation problem. VAM is an iterative procedure. The penalties for each available row and column are calculated by taking the least cost and second least cost. Approach. Step 1. Check for balance of supply and demand. Step 2. Identify the two lowest costs in each row and column of the given cost matrix and then write the absolute row and column difference. These differences are called penalties. Step 3. Identify the row or column with the maximum penalty and assign the corresponding cell's minimum supply and demand. If two or more columns or rows have the same maximum penalty, then we can choose one among them as per our convenience. Step 4. If the assignment satisfies the supply at the origin, S is equal to 0, delete the corresponding row. If it satisfies the demand at that destination, D is equal to 0, delete the corresponding column. Step 5. Repeat these steps until all the supply and demand values are 0. Step 5. Calculate the total minimum cost using the quantities and corresponding allocated values. Let us understand this clearly with an example. Example: obtain the feasible solution of the given transportation problem using Vogel's approximation method. Solution: this is the table. Step 1. Check whether supply and demand are balanced. So here we must calculate total supply by adding these 250 plus 300 plus 400, which comes to 950. Similarly, we must calculate total demand by adding these 200 plus 225 plus 275 plus 250, which again is 950. Hence here we see balance of supply and demand. Step 2. Find the penalty cost, that is difference between the smallest and next smallest costs in each row and column. Penalty P1 for first row is 13 minus 11, which 2. Here 11 is the smallest cost and 13 is next smallest cost. Second row is 14 minus 10 is equal to 4 and third row is 13 minus 10, which is 3. Similarly, P1 for first column is 16 minus 11, which is 5, second column is 18 minus 13, which is again 5, third column is 14 minus 13, which 1, and last column is 10 minus 10, that is 0. Step 3. Here among all the penalties, identify the row or column with the maximum penalty. If two or more columns or rows have the same maximum penalty, then we can choose one among them as per our convenience. Here 5 is maximum and 2 columns has it. We can choose any one. We are choosing first column. In first column minimum value is 11, the corresponding supply is 250 and demand is 200. 200 is less than 250, hence it is allocated. Now 250 minus 200 is 50 and 200 minus 200 is 0, demand 0, so column is deleted. Now, find penalty P2 for all row and column excluding the deleted column. P2 for first row is 14 minus 13, which is 1, for second row is 14 minus 10, which is 4, and third row is 13 minus 10, that is 3. Find P2 for second column as first column is deleted, 18 minus 13, which is 5, third column 14 minus 13, that is 1, and last column 10 minus 10, which is 0. Now among all the penalties 5 of second column is maximum, minimum cost in column 2 is the cell with 1, 3, corresponding supply is 50 and demand is 225, 50 is less, hence assigned value is 50, 50 minus 50 is 0 and 225 minus 50 is 175, supply is 0, so delete the row. Now, find penalty P3 for all row and column excluding the deleted column and row. P3 for second row is 14 minus 10, which is 4, and third row is 13 minus 10, that is 3. Find P3 for second column as first column and first row are deleted. These need not be considered. 24 minus 18, which is 6, third column 14 minus 13, that is 1, and last column 10 minus 10, which is 0. Now among all the penalties, 6 of second column is maximum. Minimum cost in column 2 is the cell with 1,8. Corresponding supply is 300 and demand is 175. 175 is less. Hence assigned value is 175. 175 minus 175 is 0 and 300 minus 175 is 125. Demand is 0, so delete the column. Now, find penalty P4 for all row and column excluding the deleted column and row. P4 for second row is 14 minus 10, which is 4, and third row is 13 minus 10, that is 3. Find P4 for third column 14 minus 13, that is 1, and last column 10 minus 10, which is 0. Now among all the penalties, 4 of second row is maximum. Minimum cost in row 2 is the cell with 10. Corresponding supply is 125 and demand is 250. 125 is less. Hence assigned value is 125. 125 minus 125 is 0 and 250 minus 125 is 125. Supply is 0, so delete the row. Now, find penalty P5 for all row and column excluding the deleted column and row. P5 for third row is 13 minus 10, that is 3. Find P5 for third column is 13 as it is the only value left. Similarly for last column it is 10. Now, among all the penalties, 13 of third column is maximum. This is the only cell left in third column. We have to assign value here. Corresponding supply is 400 and demand is 275. 275 is less. Hence assigned value is 275. 275 minus 275 is 0 and 400 minus 275 is 125. Demand is 0, so delete the column. Now, only this cell is left. Corresponding supply and demand are 125, so assigned value is 125. 125 minus 125 is 0. As both demand and supply are 0, the row and column is deleted. Now all the supply and demand values are 0. Next step is to calculate minimum feasible transportation cost. These are quantities and these are allocated values. Step 5. Calculate the total minimum cost using the quantities and corresponding allocated values. Here, the number of allocated cell is equal to 6 is equal to m plus n minus 1, and allocated cells are independent, hence solution is non-degenerate. Total minimum cost is equal to 11 times 200 plus 13 times 50 plus 18 times 175 plus 13 times 275 plus 10 times 125 plus 10 times 125 is equal to 12,075 rupees.